Hey guys, we are still in chapter 8 and we're still looking at factoring and quadratic equations. But right now we're going to talk about using the distributive property. And so you guys are used to distributive property in one direction. I didn't mean to make that joke. You're used to the distributive property as A times B plus C, and recognizing that you need to multiply through and you get AB plus AC. Now we're going to kind of do the reverse. So I think a better name would be the reverse distributive property, but we'll talk about that as we go along. Let's take a look at some vocabulary. Our vocabulary today starts off with the concept of factoring, in this case a polynomial, because I know you guys know what factoring is. When you factor a polynomial, you're looking to find or completely factor the completely factored form of a polynomial. That definition isn't really helpful, but it'll make sense when we talk about it a little bit later. Basically, yeah, it'll make sense. Okay. Factoring by grouping is using the distributive property to factor polynomials with 4 or more terms. So I want you to hold on to these concepts, and I think we will bring it to light a little bit more solidly when we look at some examples. And so let's get started with that. The zero product property is not an example. This is another concept that we need to know going forward. And I think it's actually kind of cool. So I want to just talk about a situation. So what if you had some number, it was like a game, and you knew one number here times some number here, right? We don't know what those numbers are, is equal to 0. Or probably the better and more mathematical way to state this would be A times B is equal to 0. What do you know? What do you know about A or B? Anything? Well, when we think back, we know that the only way to get 0 as an answer to a multiplication problem is for one number to be 0. So I do actually know a whole lot of information. This is actually quite revealing. A or B is equal to 0. So we write it as A equals 0 or B equals 0. And that seems pretty interesting and pretty neat. But the reason why this is really significant, and this is what I would usually do, is say, what if A times B is equal to 1? What could we tell about that? Does that mean that one of them is equal to 1? Well, maybe 1 is equal to 1/2. We really don't know anything. Well, we could speculate. We could say we definitely know that if this one is 5/3, then this one would have to be 3/5. So the relationship is that they're reciprocals. And that's helpful, but that's not like this. This, we come out knowing something for a fact. I know for a fact that one of these is 0. So when we just have A times B, two numbers that multiply to give me another number, that's not really all that helpful. In this case, A could be -1 and B could be -3, or A could be -2 and B could be -3/2. So we have all kinds of different things that can happen when the answer to the product of that question is not 1, is not 0, but 1 or some other number. But when it's 0, this is like a beautiful thing. And so the reason why this is a big deal, so A times B equals 0. Let me write this nicely so you can copy it down. A times B equals 0. Let's get rid of all this other stuff. You two must go. Definitely tells us that, so I'll write it all mathy. If A times B equals 0, then either A equals 0 or B equals 0. And of course, they both could equal 0, right? Because whatever. But we definitely know that one or the other is equal to 0. And so this is the math or, which is like, hey, either one, whatever, as opposed to this one. Okay, never mind. I'm not going to get into that. All right, so that's what that is. Is that okay? All right. So let's go ahead and take a look at some examples. Let me make sure you guys can see all that we're doing. It says use the distributive property to factor each polynomial. And here's the polynomial. And in a way, we're using the anti-distributive property. We're doing the opposite. So if we think about the last section that we had, we were talking about finding common factors, finding greatest common factors. That's exactly what we're going to do right now. So what would the greatest common factor of 27y squared and 18y be? You know that 9 goes into both of those numbers, so definitely 9 is going to be a part of it. And y can go into y squared and y evenly, so I factored out my 9y. What's left is, so now instead of multiplying through, I'm dividing out, right, to figure out what will go here. So 9y divided into 27y squared would leave me with 3y, and then 9y divided into 18y would leave me with 2. And so we've successfully factored that using the distributive property. So that was the first part. Let's look at the second problem. I'll do it in red so we don't get confused. as to what's going on. Okay, I'll try to do it in red. Okay, there we go. So what I'm going to do here again is to look at each term and to see if I can factor out a greatest common factor out of all three terms. I'm looking at them and see that 2 definitely can be factored out, right? And I think I put my parentheses a little too early. 2 can be factored out. Each term has at least one A term, so A can be factored out. And also each term has at least one B term. So let's see what's left. When I divide this first term by 2A, I get a negative 2AB. When I divide this first term by 2AB, I get a negative 2A. When I divide this second term by positive 2AB, I get a minus 4. Notice that the A's would cancel each other out, minus 4B. Finally, when I divide this term by positive 2AB, goes in full time, I get 1. It doesn't cancel out to 0, but it divides as 1, because when you do that, you can also, when you do these problems, you should also think about what happens when I multiply it back through. What happens when I use the real distributive property? And you'll see that we will get exactly the same thing that we started with. So we know we factored correctly. One of the terms that we had defined earlier was factoring by grouping. And one of the hallmarks of factoring by grouping is that you have to have more than 3 terms. So in this case, when we have 4 terms, if we're looking at a problem and we see we have 4 terms, one of the ways that we would look to factor is to factor by grouping. The first thing I always do when factoring is to see if there's something that I could factor out of all of the terms. And when I'm looking here, this one has a 4, this has an 8, so maybe I can factor out, but this is a 3. I can't factor a 2 out of that. That's prime. And so factoring by grouping, you might want to try to, every time you come to factor, you want to look to see if you can factor out of everything. But you know you have a factoring by grouping situation if you have 4 or more, and if you realize that you can factor something out of 2 terms and factor something else out of 2 terms, such that what's left is the same, and I'll show you what I mean. So what I'm going to do here is factor out of these 2 terms. And honestly, you could oftentimes change the order, but usually it's nice to just factor out of whatever the first 2 things you see. So I'm going to factor out of these 2 terms, and I'm going to factor out a 4 and an R. And what I'm left with, I'm only going to deal with these terms for right now, is I'm left with Q plus 2. Take a moment to make sure you see that you can multiply through and get back exactly what we had with these first 2 terms. Then next, I'm going to factor out of these 2 terms and just put a little plus sign here. So because this is positive, I'm going to factor a positive 3 out, and I end up with Q plus 2. The thing here that I want you to notice is the fact that we are left with a Q plus 2. This is important because when you're thinking about this, this is kind of like the distributive property. Let me show you what I mean. So if this problem were like this, if it were, oh, that's not what I need. If this problem, sorry about that, people. If this problem were 4R times A, right, plus 3 times A, you would tell me that, I'd say, okay, let's see if we could factor something out of both terms. And using the last method that we did, you'd see that the A's are the same. You'd factor the out, and you get 4R plus 3. And you'd feel pretty comfortable because you know if you multiply back through, you would get the same 4RA plus 3A, right? We're going to do the same thing here, but this time, let me get this other stuff out of the way. But this time, what we're looking at is not an A term, but a Q plus 2 term, right? Which is not something we usually think about factoring. But notice we've got the same factor for each of these terms. So we're going to factor out a Q plus 2, my people. It's happening. So Q plus 2 comes out, right? And what's left? It's 4R plus 3 is what's left. And our Q plus 2 is simply what was there highlighted in blue, right? So this is what came out. And what would happen if I multiplied it right back in? I would get the same thing. Kind of funky, right? A little bit weird. Take your time, review this, go over it. If it didn't feel comfortable, you'll have plenty of practice to look at it in a moment. All right, I had to do a little bit of editing there, but we're going to talk about this problem. The reason why, and I'll do this over real quick. Okay, the reason why this problem is under the concept of factor by grouping, we're going to have a little bit of a twist, so I want you to pay attention. So basically, we're going to do the same thing. We're going to factor by grouping. We're going to see what we can factor out of the first 2 terms, because I can't take something out of all terms. So 2mk, I can factor out a 2 and an m if I'm just looking at these 2 terms. So I'm left with k minus 6. Do you guys see that? Because 2m times k is 2mk, 2m times 6 is 6m. All right, so I'm going to do a similar thing here. What can I factor out of these two terms? 7. And I'm left with 6 minus k. Now, when I do factoring by grouping, I want these guys to be exactly the same. And when they're not, that means this might, if it doesn't work, that means it might not have been a factor by grouping opportunity. It doesn't work out. But as I look closely, I see k minus 6 and 6 minus k are really similar. In fact, they are additive inverses. And how can we take care of additive inverses? By the -1. So by using -1. So 2m times k minus 6. I wonder what would have happened if I factored out a -7, right? If I factored out a -7, I would have ended up with a -6 and a positive k. All right, take a moment to look at that. And then now, 2m times k minus 6 minus 7 times, I can rewrite this as k minus 6 as well. And voila, I get exactly what it is I want. I get similar or a common factor out of two larger terms. So what I've done is I've basically said with the 4 terms, right? I'm basically looking at is call this one big junky term and call this one big junky term, and I'm factoring out of those 2 junky terms, okay? And so when I do that, let me get my pen back again. When I do that, I'm ending up with, I end up with k minus 6 is being multiplied by 2m minus 7. And so let me go back here and get this guy. And so this is the part that I factored out, all right? Does that kind of make sense? I'm hoping so. So sometimes you have to do a little bit of finagling, and that's what we got to do with that -7 there. And so we have a couple of problems left. And what I want you to hold on to in these problems that are different than the other ones is that there's an equal sign. And I know that seems rather trite, right? But when there's an equal sign, that's when you're being asked to solve. You can't solve an expression because there's nothing to solve. The only thing you can do is simplify or factor an expression, and that's something that you want to think about or keep in mind. So the key to solving these problems is that property we talked about. Do you remember A times B? When we said A times B is equal to 0, therefore A is equal to 0 or B is equal to 0? Well, this is really the same situation. So as I look at this problem, I recognize I've got two factors, right, that are being two factors that are being multiplied together that gives me 0. So that tells me that 2d plus 6 equals 0, or 3d minus 15 is equal to 0. So what do you do with that? Well, you figure out what d value would make it 0. So here with this problem, with this portion, I've got 2d plus, that's not a d. I got you people, I know. You're going to be telling me, Dion, you messed up. Okay, 2d plus 6 is equal to 0. I'm going to solve by moving my 6 over to the other side, so I get a -6, and then dividing both sides by 2. D is equal to -3, or I've got another situation that D could make this whole thing 0, and that's if 3d minus 15 is equal to 0. So I'm going to add 15 to both sides, like I know I should. So 3d is equal to 15, which tells me that when I divide both sides by 3, d is equal to 5. So for this solution, the solution to this problem has 2 answers, and that's d is equal to -3 or 5. We're going to do this next problem. I'll try to do it in another color so that it makes sense. This is a quadratic equation, and the reason, both of them are quadratic, and the reason why I know is if I were to multiply this together, the highest agreed term I'd have would be squared, and here clearly I have a squared term. When we solve quadratic equations, it really makes sense for us to have it equal to 0. That is like a #1 law that we're going to use, and so c squared minus 3c equals 0 is the preferred way to start off by solving this problem, So what I would do at this point is factor a c out of both sides, or factor a c out of, well, not both sides, but both terms. So I get c times c minus 3 is equal to 0. And you remember the law we just talked about? When you have two things being multiplied and that gives you 0, you know that one of those bad boys has to be 0. Well, c is either equal to 0 or c minus 3 is equal to 0. And we're going to test out both of those situations. If c is let's do it again. If C is equal to 0, and C is equal to 0, and we're done. So that is one solution. The other solution is C minus 3 is equal to 0. If we solve for C in this case, we get that C is equal to a positive 3. So the two answers we get would be C is